Okay, now let's talk about monolithic architecture versus microservices architecture. So typically monolithic application has a single code base, and typically they consist of three layers. For example, the UI layer, business logic, and the data access layer. So these all are contained in one executable file, for example a jar file, and then this entire application is developed and deployed and also scaled as a single unit. So we're going to have multiple modules within these layers, and then one single database to talk to. Then when we build this application, we can create one executable file which we can deploy. So this is a monolithic architecture. However, microservices architecture is basically an application that is composed of multiple microservices. So these are multiple small independent services, and each of these service is responsible for a specific functionality, and they can be deployed, developed, or scaled independently. So these services communicate with each other through APIs, typically over a HTTP or messaging system like Kafka or RabbitMQ. And then one main difference that we can see is each of these services have their own database. So unlike monolithic, microservice application have their own databases. So these are the differences between monolithic and microservices architecture. Now, one main difference is that the microservices architecture is basically loosely coupled services. These services are not coupled, or they are not closely dependent on each other. So however, this is not the case in the monolithic architecture. Okay, so in the case of microservices, since we're going to have multiple services talking to their own database, so how are we going to deploy this? So we're going to create one artifact out of each of these services. So how do we make sure each of these services talk to each other and contribute to the application? So this is where Docker comes into picture. So Docker is basically an open source platform that automates the deployment, scaling, and management of applications within lightweight and portable containers. So the main idea of Docker is basically to create containers. So container is basically the running instance of an image. So the main idea is we're going to create Docker image out of our application. So that Docker image is going to include the code files, the source code, all the libraries and the dependencies, and also the runtime that is necessary to run this application. So everything will be packaged as a Docker image, and then when we run that image, it's called as a container. Okay, so this is the basic architecture. And one more thing, when we create a Docker image, we can run that image. So when we run that image, it's called a container. Okay, so in case we don't, so this is like our local computer where we have installed Docker. So if we don't have these images locally, we can pull these images from Docker registry, for example Docker Hub. So once we pull these images using these commands like docker pull and the name of the image, then we can run these images to create a container using this docker run command. So this is the basic Docker architecture, and the workflow basically is we're going to have a Docker file in our application, and then that Docker file is basically contains the instructions on how we want to Dockerize our application. So by Dockerizing an application, I mean how do we want to create Docker image out of our application. So we're gonna put our source code, dependencies, and also include our runtime environment. So all this logic or the instruction is written in a file called Docker file, and then we can build that Docker file to create a Docker image, and then we can run this Docker image, or we can push this image to container registry. So one problem that we have is some applications running on one machine and it's failing on the other machine. So this is the problem the Docker is trying to solve. So basically this is going to ensure that application can run consistently across different environments, from developers laptop to cloud servers, because Docker images are going to contain everything that is necessary to run a system or an application. So from the source code, libraries, dependencies, and also runtime environment. Okay, so in the next part we're going to cover Kubernetes architecture and components.